Hello, dear student. How are you? I hope you all will be fine. I'm also fine. Thank you. Welcome to HN Data Science Group. Let's start today's topic. Today, I bring a new mechanism of organic chemistry, that is Claisen condensation. In Claisen condensation, that is a very important organic mechanism. So in this reaction, we use the ester group, that is here in this mechanism I use the ethanoate, that is ethanoate. So in this group, in this mechanism, one that is a medium it used, that is also called alcohol, which can be dissociate into cation and anion, and the anion will be act as an nucleophile, or it will be act as a base. So the difference between nucleophile and base is that nucleophile will be attack on the carbon atom or in any center, while base will be attack on, or base will be abstract any proton from the any substrate. So that's why it will be act as a base, because this ethyl group, this ethyl group will be act as a that will be abstract a proton from this compounds. So this ethanol group is will be act as an base, and it will be abstract this proton from this ethanoate groups. So this is ethanoate. Let's start the mechanism. This is ethanoate groups. First of all, this base will be act, this group will be this attacking group will be act as a base, and this will be abstract this proton. When they abstract this proton, it will be act as a, it will be form C2H5. Here is OH, that is missing. Here it will be become OH, C2H5OH. OH. Here you can write OH, or you can say when here is OH, when air is completely ethyl alcohol. So that's why here when here is already H present, so C2H5OH. When another H come to here, or when another H was abstracted from the another compound by this ethyl alcohol, so that's why here will be H2O produced. So this H2O can be leave this group, so that's why C2H5 will be produced. So this C2H5, and here is CH2COOH, because when this H was abstracted, the bond was shifted toward this carbon, so that's why this carbon has negative charge. So that's why this carbon will be act as a nucleophile. It can, you can write this, this is not lone pair, that is just the book mistakes. So this carbon will be act as a nucleophile, that will be act, that will be carbanion producer. So this carbanion will be shifts, this carbanion will be attack on the another ethanoate group like this, that is ethanoate group. So this carbanion will be attack on this the carbon, that is when here is carbonyl group present. So the carbon of carbonyl group, it will be attacked to this nucleophile. So it will be attack on this nucleophile, and the double bond between carbon and oxygen will be shift towards oxygen. So because oxygen is electronegative element, it withdraws the electron. So that's why bond produced between this carbon, and it will be produced like that, and this oxygen will be get negative charge because of the double bond was shifted toward this oxygen atom. So this compound will be produced. Everything is same as here, but in this case that is CH3C single bond OCH2 CH. Here is here is one thing, here this is negative charge. Here is some book mistakes, and this is book mistakes, that is the book other write the negative charge on this carbon, but this is wrong, because when the negative charge on this carbon, actually this negative charge on this oxygen, when the negative charge on oxygen, this will be shifted towards here, this lone pair will be shifted towards here, and here it will be produced double bond. So that's why the oxygen will be get neutral, like here in this case, but carbon has already completed their covalence, so that's why one bond should be break from carbon. So the bond between carbon and oxygen, or carbon and ethynyl groups, it will be break down. So this way that it will be break down, and it will be generated as before when they use as a catalyst, or when they use as a medium. So it will be go into the medium, because they are started from the medium in the reaction. So that's why this compound will be produced, that is the negative charge will be shifted here, and here is double bond produced between carbon and oxygen. So this carbon and oxygen will be, this bond will be produced, that is one, you can say that is ethanoate also, as well as it is here one ketone group, ketonic group and ethanoate group, both groups are present here. So plus also that is the, first of all, when the reaction was started from this groups, it is generated again in the reaction, because it is used as a catalyst. So the compound that was produced, so this compound, the C2H5O negative, that can also be attack on this compound, and they will be abstract a proton from this carbon, that is the carbon between inside. Here the structure of this compound is C double bond O CH2. Here is this O will be double bonded with this carbon, it will be like this C double bond O, and this will be bonded with the O, and this carbon will be bonded with the single bond O, and this O will be single bond with C2H5. So it will be like that, but here in both carbonyl groups, the carbons, the Sg2 group that is present in both carbonyl groups, that will from this carbon the hydrogen will be abstracted and negative charge will be produced on this carbon, while C2H5O it will be changed into ethyl alcohol. So here that is also called ethyl alcohol, or also called ethanol. So it will be shifted into change into ethanol. But here in this carbon here is negative charge producer. So this negative charge that is resonance stabilized, because on both cases on the both side, either side, the oxygen is present with double bonds. The oxygen is attached with the carbon with double bond. So that's why one double bond can be shifted towards oxygen, or one double bond can be broke towards oxygen. So that's why this negative charge can be used. His resonance it will be localized. So this double bond, this negative charge will be shift here, and here it will be produced to carbon double bond. So that's why this double bond between carbon and oxygen will be shift towards oxygen, and oxygen will get negative charge. Also this negative charge can also bond it between carbon and carbon. So carbon make double bond, while this double bond between carbon and oxygen will be shift towards oxygen, because oxygen is electronegative. So that's why the bond will be shift either one side. So that's why this compound will be resonance stabilizer. And again this is resonance stabilizer, and the whole compound here is negative charge present. So this negative charge can be stabilized by when one another compound, that is sodium, when we use the sodium, or when we use the that is any base or any metals, so it will be stabilized by this. So that's why CH2, this compound, this is and this compound here is one negative charge, while sodium has one plus charge. So the compound will be stabilized and salt will be produced, that is salt, neutral salt. So these are the compounds, and this salt can also be replaced by when another carbonyl group or carboxylic group use as a nucleophile, when the another carbonyl group used as a catalyst or as a solvent, it will be produced generated into again the same compounds as we started from here. Okay, this is the mechanism about called Claisen condensation. I hope it will be clear. Still, if you have any confusion, if you have any question, you can ask me in the comment section, as well as you can ask me in my personal, or give me the type in the description box, you can get from there. Okay, thank you very much. Very best of luck, my very best of luck.